Hi, and welcome. My name is Caleb Hong, and today I'll be teaching you how to balance chemical equations. So first, we have to determine what exactly balancing a chemical equation means. The main goal of balancing is to make sure the number of atoms of each element on both sides of the equation is the same. And once balanced, the chemical equation tells us the ratio of reactants to products and is also useful in stoichiometric calculations. Now, let's use this PHET simulation to help us visualize what exactly we're doing when we balance a chemical equation. So here we can see our unbalanced equation is nitrogen gas, N2, plus hydrogen gas, H2, yields ammonia, which is NH3. So what we're trying to do here is determine what ratio of the three substances is required to balance out the number of atoms of each element on both sides of the reaction. So if we add one ammonia, then the scales for both nitrogen, which is here on the left, and for hydrogen, which is here on the right, tip in favor of the products. So now we have to figure out a way to make the scales balance themselves out. Because there is only one nitrogen and three hydrogens, another ammonia must be added. Now going to the reactant side, we can see that by adding 1 and 2, the nitrogens balance out on both the reactant and product side. And similarly, if we add 3 H2s, the hydrogens balance out. So that was a pretty basic example, but now let's break down the process of balancing a chemical equation that will make it easier for examples that are more complicated. So here we have the unbalanced chemical equation for the combustion of propane gas. So the first step is to usually start with the most complex molecule. In this case, that would be propane because it has the most atoms. So with one propane, we now have 3 carbons and 8 hydrogens on the reactant side. So now we have to balance out the 3 carbons with the CO2, since it is the only product which contains carbon. So 3 carbon dioxides gives us 3 carbons, which balances out the 3 carbons in the reactants, and 6 oxygens on the product side. So now we have to balance out the 8 hydrogens. Water vapor is the only product which contains hydrogen, so to balance out the 8 hydrogens on the reactant side, you need 4 waters. This gives us 8 hydrogens and now 10 oxygens, 6 from the 3 carbon dioxides, and now 4 of them from the 4 waters. In order to get the 10 oxygens to balance out, add 5 O2s on the reactant side, and we're finished. Okay, so now let's look at a more complicated example. Our unbalanced equation here is for the combustion of ethine, which is the C2H2. So the first step, as previously mentioned, should be to start with your most complex molecule, which in this case would be the ethine. With one ethine, we now have 2 carbons and 2 hydrogens. And in order to balance out the 2 carbons, we're going to want to add 2 carbon dioxides on the product side. And to balance out the 2 hydrogens on the reactant side, we're going to want to add 1 water. This gives us 5 oxygens and 2 hydrogen. From here, the 5 oxygens are not going to be able to be balanced out by the O2 on the reactant side, so we're going to have to start over again and add another ethine. Now we have 4 carbons and 4 hydrogens on the product side. To balance out the carbon, as we did before, add 4 carbon dioxides to the product side, which gives us 4 carbons and 8 oxygens. Then add 2 waters to balance out the 4 hydrogens, and that also gives us 2 more oxygens for a total of 10 oxygens. Finally, add 5 oxygen O2s on the reactant side to balance out the 10 oxygens. Okay, so now it's your turn. But before you go ahead and start working on this problem, here's a reminder of the steps you should take. Always start with the most complex molecule, and then manipulate the remaining molecules so that all the components balance out. Remember, you may need to go back to the most complex molecule if you hit a dead end, like in our last example. When you're finished, always check your work to make sure there is an equal number of each element on each side of the equation. So now you can go ahead and pause the video to work on the problem before I reveal the answer. So here's the answer. It's 4 ammonias plus 7 O2s yields 4 nitrogen dioxides and 6 waters. So hopefully you now better understand how to balance chemical equations. Thank you for watching, and I hope that was helpful.